Hey, are you sure? 90 degrees clockwise. So. Okay, so let me teach you the trick I've been using. Are you there?
Yes, sir.
Whenever we are doing enlargements and we are doing rotations, right? And they give you x, y, and they ask you to find, or they give you any point. Now, this is what I've been doing. Take it as if you are the human being here, right? And in your head, you are thinking about your x. Let me draw a circle. So in your head, you are thinking about your x. Maybe you are worried. So in your mind. So you say x. Maybe your x has left you. Now you are alone. You say x, y, x, y, x, y, x. You see x, y, x, y, x, y. See some of the x's, they are liars, they are snakes. So you draw an S like this. Draw an S. Like so why? So why did your x leave you? So that S that you've drawn, it is actually negative. Do you understand? Oh, where is this thing? Are you getting me? So let's draw it again. Or even if you are not starting with x, you have it in mind that something you are trying to remember the formula, but you don't remember the formula. So you're asking yourself why x, y, x, y, x, right? Then you negate all these ones. It's like drawing an S, right? Drawing an S. Are you getting me?
Yes, sir.
So let's draw it again. Where do we start from? We start from y. We want to remember the rotation questions. Why? So why? X, y, x, y, x, right? Then we draw S, S. You get the idea?
Yes, sir.
So wherever the S will pass through, that is the what? That is the rotation formula. So right here, the first one, because we are moving in this direction, if you are moving in this direction, everything is like a clock. You see clocks, they move in this direction, they move from here to here, right? So this is what? Clockwise, clock. So the first one becomes 90 degrees clockwise, the second one 180 degrees clockwise, the third one is 270 degrees clockwise. And when you are coming back like this, it's anti-clock. Like this, anti-clock. So this one becomes 90 anti-clock, 180 degrees anti-clock, and 270 degrees anti-clock. Are you okay? And if they give you the angle, maybe 90 degrees, and they don't add anti-clock or clockwise, it means it is anti-clock. Are you okay?
Yes, sir.
Very good. So let me see if I can get some rotation questions here. Inside the PDF. Rotation, transformations. Yes, transformations. Let me see. So the transformations, there are different types of transformation. We have the transformation with a matrix, the transformation with a vector, and different and enlargements and rotations. So let me give you something like this. So something like this. Let me bring this one here. It says the point 51 is rotated about the origin 180 degrees. So this 180, they didn't write whether clockwise or anti-clockwise. So because it can't specify whether it's clockwise or anti-clockwise, it is anti-clockwise. You understand? When they don't put anything on it, right, it's anti-clockwise. Or you can hide your camera screen. I'm trying to stream on YouTube. Are you okay? So over here they give us the point -5, 1, right? And we want to move it 180 degrees. Now I said when they don't write clockwise or anti-clockwise, it means it's anti-clockwise. So the 180 we come and choose what's the middle one. So that's -x, -y. And we said that wherever the snake will pass through, it will become negative. So over here, the negative 5, 180 degrees is going to be what? This one is what? X. The x will come here, but it's going to be negative, so positive 5. And the y will come here, and the y will be negative. So the answer is 5, negative 1. 5, negative 1. But that's option B. I hope you understand.
Yes, sir.
Very good. Let me see if I can get another one. So this one. The point 3, 1 or 3, negative 1 is rotated what? 3, negative 1. It's rotated 270 clockwise. So whenever you are doing rotations and they give you this clockwise, you just write this formula. Let's remember. Can you remember how we wrote the formula?
Yeah.
Yes. Can you remember how we wrote the formula? You start from y. And what do you do? Hello, are you there?
Hello?
Yeah, are you there?
Okay, I'm back.
Is that?
I'm here.
Yes, I said, do you remember how we wrote the formula? You start from y, x, y, x, y, x.
Yeah.
Okay, let's start again. Y. You're asking yourself why.
Y.
So y, x, y,
Y.
x,
X.
y,
Y.
x.
X.
Right, so you form a triangle of x's. This triangle, x, x, and and another triangle, y, y, and you get a pattern. So hope you understand. Then after that, you draw a snake like this. So wherever the snake will pass through, everything will be negative over there. Okay. So in this case, that way we just did 270 degrees clockwise. Clockwise means the last one, 270. So y, negative y, and what? Positive x. So the 3, negative 1 is going to be negative y. The y element here is going to be negative and come to the top. So it's going to be positive 1. And the x2 is coming to come down. So that's the answer. 1, 3. That's option B. Are we okay? Are you okay?
Yes, sir.
Okay.
Yes, sir.
All these one, they are objectives. Let me see if I can get another easy one. Another one is here. So the transformations they are very, very easy. So this is another one. Let me bring it here. It says if P prime is the image of P negative 2, 4 under the clockwise rotation of 270 about the origin, find the value of P prime. Right? So Papa say you rotate here at the end under 270 what clockwise, right, from here to here. The answer we got was negative 2 and what 4. So find the actual P. This is P and this is P prime. So find the actual X and Y. Right? Now we know that anytime we are given 270 degrees clockwise, what should be the answer? It will be Y negative X. Right? So we know that it's going to be what? Y and negative X. Right? So if this Y is positive, it means this Y will come down as what? Negative 2. Do you understand? Let me do it this way.
Yes,
XY maps to what? Y negative X. Right? So if this is true, it means this one will match this one without any negative. So it means here is negative 2. But this one will also do what? Hey, sorry. It should be what? Negative YX. here is negative y, and here is positive x. Right? So it means if here is negative y and here is positive x, it means this 2, it should be what? It should be positive. Are you okay? Are you okay? And this x is going to be what? Positive. So 4, 2. 4, 2. That means if you have 4, 2 here, you are sending it 270 degrees clockwise. It's going to be what? Negative 2, positive 4. I get me. I hope you understand.
Yes, yes, yes.
Okay, now the next thing I want to talk about is what? Translation. Translation means you are changing the element. If I say BB or I say I'm move it without changing the shape. Right? The thing is here, I just move it here. So I've translated it. If I move it here too, I've translated it. So the movement goes in X and Y. If I move here, I've moved maybe X, the thing was here. From here to here, maybe how many units? 3 units to the X. So X equals 3. And if I move it to the top, then I'm missing back here. If I move the same thing to the top, it means I've moved it Y units to the top. So let's say Y equals 2. Right, so this is the transformational vector. Do you understand? So in transformation, you just add. Did I say transformation? In translation, you just add. Are you okay? So a typical question like this. A typical question like this is the translation vector T makes the point dash to this. Find the image of the point -1 under T. Right? So whenever we are doing translation, it's I equals what? T plus O. But when you go to vectors, it is what? I equals what? T M O. Vectors, you are doing transformational metrics. I say vectors. When you are doing matrices, you are doing transformation. Transformation means I didn't make a C and I make it to. But translation means you are just moving it left or right. Whilst transformation means you are enlarging it, you are transforming. Those are transformers, almost a car. When the transformers are like cars, they transform to become like human beings. They stand up upright. Do you understand? Are you okay? Are you okay? But this one is a translation vector. So now they say that the translation vector T makes the point this to this. So it has translated the object through a translation vector to an image. So this is the point 1, 1 to what? 3, 4. Right? So it means the image is what? 3, 4. It adds to a transformational vector plus the object 1, 1. So if you want to make T the subject, it's going to be 3, 4 minus what? 1, 1. So 3 minus 1 is 2, 4 minus 1 is 3. So this means this is the translational vector. Now they said find the image of the point what? So object, image of the point under this one. So down T plus what? O. Now I want to find the image when this translational vector 2, 3 is being used on the object of -1, 2. This object. Right. Are you okay? Do you understand? Hello?
Yes, sir.
So 2 plus -1 is 1, and 3 plus 2 is 5. So 1, 5. Are you okay? Option B. And anyway, the answer is in option B, option B. Oh, the answers are so far. Yeah, option B. Let me see question 1. Okay, let's continue. So let's look at number 3. In fact, let me share the whole screen here. So that's translation and transformation and all those stuff. When they say enlargement, it's our WASSCE factor. Now over here, they say the point 2, 1 is reflected in a line. Right? Those enlargement things, they are very easy. There's a song I heard online. It says, rotate, turn it round, translate, shift it left, right, up or down, reflex, copy it across an axis of symmetry. Right? So if you are reflecting it, you are just copying it across an axis of symmetry. So the point 2, 1 is reflected in a line x equals 3. Right? So if maybe this is our x-axis. And this is a line x equals 3. So x equals 1, x equals 2, x equals 3. Right? X equals 3. This is the line. And we have the points 2, 1. So if I say 2, 1 over half. So 2 on x, 1 on y. Right? It's reflected on this line. What will be the image? The image is it's like image distance equals object distance. So the distance between here and here is 1. So automatically the image is always going to be what here. This is the image and this is the object. Do you understand? So the image is going to be what? 4, 1. 4, 1. That's option D. Please, do you understand?
Yes, sir.
Yes. So it's like a mirror. So you have to know your line of symmetry or the line of reflection. Now they say the image of the point, this, and then the reflection of the line is, find the image of the point, negative 12, 4. Under the reflection of the line y equals 3. So we can still use this same drawing, clean this element. So it says find the image of the point 12, 4. Hey, 12, 4. If I say we have 5, 10, 15. One paper. So let me use 3, 1, 3. 3 times table. 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12. Oh shit, look at me, bro, a negative 12. So negative 3, negative 4, negative 6, negative 8. Hey, 3, 1, 3, 3, 2, 6. Hey, I'm sleepy here. 3, 1, 3, 3, 2, 6. 3, 3, 9. 3, 4, 12. So negative 12, 4. If I say I had 2. Now we have 4. Negative 12, 4 is here, right? It says, find the image of this point. So this is the object. In the line reflection of y equals what? 3. So this is the line. 3 is here. So y equals 3 is a line passing through 3. So if you want to see the reflection on this image, is the distance between here and here. Which is what? 1 unit. So it means the image will be here. Image is going to be negative 12 and what? Negative 12, 2. Oh, I didn't do it well. 4. The distance between 4 and the line x equals negative, y equals negative 3. Oh, sorry. The line should be y equals negative 3. The line should be y equals negative 3. So maybe here's negative 2, negative 4. And here will be negative 3 in between. So the line should pass through this one. Right, so now I'm going to count the points from here to the line. So over here, if I jump from here to here, it's 2 points. If I come to the x-axis, this is 2 points, so 4. If I come back to 2, 6 plus 1, 7. Right, then I'll count the same 7 points downwards. Please, do you understand what I'm saying?
Yes, sir.
So if you are counting 4, from 4 to the line y equals negative 3, up to the origin is 4. Then you come downwards 5, 6, 7. So 7. Then you count 7 to from 7 back to 7. 7 to 7. You're going to get 14 also. Negative 3. So negative 3 minus 7. What are you going to get? Negative 10. That's for the x, the y value. So look for a y value that has negative 10 there. So that's option D. Please, do you understand?
Yes, sir.
Because over here at y equals 3, you'll be going downwards 7 times. Because the distance between here and here is 7. Then you go down again 7 times. So from negative 3 plus 7, you're going to get negative 10. And that will be the image. So I don't want us to waste much time on it. You said you had issues with bearings, eh?
Yeah.
Yes. Let me see if I can get some questions for you. Just like we did in the emails, eh? So let me see if I can get more than ones. Now it says this one, a bearing of 320 degrees expressed as a compass bearing is what? Hey, you call your guys, they didn't join, eh? They are waiting for, listen, Apocron. So right, you say that a bearing of 320 degrees expressed as a compass is what? As a compound bearing. So in a compass, north, south, east, and west. So 320. So the whole listen, this is 90, 270. So 270 plus 1 will give you 320. But basically, let's say 320 minus 270. 320 minus 270. $50. So it means you are going to add 50 in this direction. That means it's going to be 40 here. Right? And in bearings, we read from the north. So you are reading from here to here. So the angle is 27 plus 50. 320. It's going to be north 40 degrees east. Do you know why? Because I say east west. Not 40 degrees west. Right? Because if I'm reading from here and I want to come west, I'll come in this direction. What do you understand?
Yeah.
So I'll come in this direction. I'll come from the north, approaching the west. If it is like this, you'll be approaching the east. The same thing for the south too. Are you okay? So north 40 degrees west. North 40 degrees west. Are you okay? Oh my god.
Yes, sir.
Man tired. Oh my god. I have to sleep. Let's continue. Sami moved from point M 6 kilometers due west. So this is Sami. Always draw the cardinal point. Sami, you do geography. So Sami moved from a point M. So this is M, the point M. 6 kilometers due west. West means you are going like this. West Africa. Sure. I didn't draw it, so I have to come and bring this one in the middle. From Shaha, baby. Great Sami. So you move what? 6 kilometers due west. West is a straight line. Right, 6 kilometers due west to a point K. Then 6 kilometers on a bearing of 300 degrees. So from here, 300 degrees, you are ready from here up to 300. So 270 plus will give you 330. So that small angle here is 30. Are you okay?
Yeah.
So what is the bearing of L from M? So this is the L, they highlighted at L. So what's the bearing from L from L? What's the bearing of L from M? So let's connect this one. It says L from M, so this is the direction. L is coming from M. L if M na oba. You understand? So now you know that that's if here is 30, this small one, this small angle from here to here is 30. From here to here is 8. And from here to here is 30. So here now is 30. From her up to WASSCE. And the higher 60. And I say here 60. Right. Now here is 90. And they say what's the bearing of L from M? We are looking for this thing. From here up to this line. So going, L from M. So how do you think you are going to solve it? And okay, he has this place is 6 kilometers. So we don't know the distance from here to here. What's the bearing of L from M? The bearing, you're looking for the angle. Can you draw this diagram, or I should draw it again? Can you draw it? I even want to draw it again because I didn't do this thing. The question looks funny. Sami moved from point M. So this is point M. 6 kilometers. Due what? West. Now I see me draw line maybe sir. So 6 kilometers to a point K. He then moved 6 kilometers on a bearing of 300 degrees. So 300 degrees. Right, so it is 270 plus what? 30. Are we okay? So here is 60. If we get a line here, and we say that point is the L. If here is 30, here is also going to be 30. And here is going to be 60. And here's place 2 is going to be what? 60. I didn't draw the diagram. How can 30 look greater than 60? No worries. Let me connect this and this. Where am I? Send this and this. Hey. I'm going for shapes, not for drawing. I'm ready to black. So now let's what? Here's also 6 kilometers. 6 kilometers. I say bearing of 6 kilometers. 300. So this is 90. This place is 90. So now if you have 60 over there, 6 plus 9, 15. This is the whole angle here is what? 150. Now they want us to find the bearing of L from M. This is how the journey started. L from M. I'm trying to use vectors, but I don't know. Okay, vectors are easy. Now the whole angle here is 30 degrees. Right. You can use cosine rule to find this one. Because we know that this angle. Then after we find this distance, we use cosine rule. This and this will work, and this, so that we find the back bearing from here up to here. We just need a small angle theta to find. That's our whole assignment. And in the question, we don't have any other theta elsewhere, so we have to use cosine rule. So the d square was 6 square plus 6 square minus 2 times 6 by 6 cos theta. So let's punch everything in the calculator. 36 minus 72. Because 6 times 6 is 36 times 2, 72. Okay, this one is having cos theta attached to it. So d equals the root of 6 square plus 6 square. This one is even an isosceles triangle because if here is 6 and here is 6, I'll find it easily. Yes, isosceles triangle, so you don't even need cosine rule. Please, are you okay? And are you there? Because it's an isosceles triangle, you don't even need a cosine rule. Because this triangle is like this. Here's 6, here's 6, here's 150, here's theta, here's theta. And we are looking for only the one of the theta. So theta plus theta. Hey, you see you do me light. Oh, nice, you will be rough. Equals to 180, right? So 2 theta equals 30 degrees. Then theta equals 15 degrees. Right, so it means here is 15. Then when you add 270 to 15, what are you getting? 270 plus 15. What are you getting? 285, and that's option B. Are you seeing that thing? Are you okay?
Yes, sir.
So this one we took some time, Kakra. There's more I will have to do, but I'm tired. Can we wake up in the dawn and start learning?
No, before exams, I relax.
Is it?
Before exams, I still relax.
Okay, it's true. Now let's continue. A ship sails 5 kilometers due west and then 7 kilometers due south. Find the correct direction of this. So are you getting it now? The bearings, are you getting it now?
Yes, sir.
Let me bring another question. Now a ship sails 5 kilometers due west. So this is a ship. Always we have to know this thing. Or west there and if I to have baby. So this is the directional north. 5 kilometers due what? Due I'm going to draw. 5 kilometers due west. West is like this, so West Africa. This is the direction. 5 kilometers. And then 7 kilometers due south. So due south means you are going down. Where we need to due south. So from here, things went south. Due south, so that's the arrow. And here's 90 degrees. Find correct to the nearest degree the bearing from its only. Find correct to the nearest degree its bearing from the original position. So we should look for its bearing from the original position. From the original. So from let's say if he has a, I'm taking something from this one. So this one is the latest. So from, do you understand? From the original. So this is the original position. And this is the west. And this is the south. Right, south. Right. So they say find the correct to nearest degree its bearing from the original position. Right. Now, if from here to here is 5 kilometers. And here is 7 kilometers due south. It means you can use what? Pythagoras theorem or Sukatwa to find the angles and all those stuffs. Are we okay? Do you understand?
Yes, sir.
So now we are looking for the angle from here to here, right? But if you're able to find this angle theta, we subtract 270. You see everything here is 270, so 270 minus theta will give us the rest. Right, now because here is south, here is 90, here is 5, here is 7. This means that to find the angle you can use Sukatwa. So Tuasuka or Sukatwa, Tuasuka. So this is opposite. So I'm going to check all the opposites. And this one is adjacent. So adjacent. The one with the 2 corners is one we use. So this question it was tan theta equals opposite over adjacent. The theta is going to be what? Tan inverse of what? 7 over 5. So tan inverse of what? Tan inverse of, I I didn't come here from 7 over 5. 7 over 5. 54.4. So 54.46. That's the angle here. So this angle, the TF 270, because the whole quadrant over there adds up to 270. So 270 minus the answer. Or better still, you can write 270 here minus the tan what to do. You are getting 215.5. 215.5 degrees, which is around C. Please, do you understand now? Why are you getting it?
Yes, sir.
So that's how we solve variance questions. For you people, almost all your questions in variance, commas, all your questions are around for instance, Pythagoras theorem and what? Sukatwa. Right. Now there's another one here. Write the bearing 151 in compass direction form. And that's what you've done it before. You've done it. It's easy. So apart from bearing, which one do you have issues with? Apart from bearings, which one do you have issues with? Apart from bearings, which ones do you have issues with? Warren? Are you okay with the maximum and minimum curves of quadratic graphs? No?
That one doesn't come often.
Sure, sometimes it's common. When you come as you can't predict too. Everything will come. Everything can come. Come as it's deep. Everything can come. When they actually find a minimum and maximum points and those stuff, can you do it? Let's do one of them. So let me bring this objective. Let me share my screen rather. Let me share my screen because this one. Echo Mensa Wobel. Are you there?
Yes, sir.
Are you not gonna?
No.
Aquinas.
I'm in
Minibar. Okay. We are live on YouTube. Okay. So yeah.
Okay.
Okay. So now look at this question. I like to open this one from the Microsoft Word browser. It's really fun. Edge browser. Open with Edge. Shampam Osbisa Ila Iridi Everybody do what you do. Smile will bring the sunshine day. Everybody do what you do. Smile will bring the sunshine day. Me day. Okay. I'm coming. What were you doing? We were doing quadratic equations. No, quadratic graphs rather. Hey, quadratic equation. I hope you can all do it. Mode 5-3.
Yes, sir.
If it's a fraction, you know how to do it. If it's a fraction, do you know how to do it?
Yeah.
I'm listening. For example, this question. Can you do it? This question, find the truth set of this one. Maybe you can do it.
Hey.
What's A? This one is easy. You go to your calculator, mode 5-4. You know, mode 5-3. Mode 5-3. Then you press 4, you press -16. And press 15. I mean question what? Which question are we doing? Question 12. 5 over 2, 3 over 2. So you just change 5 over 2 to what? Into next form. Next fraction form. 2.5. And what? 1.5. Simple, you are gone. You have to over. So quadratic, I'm sure you guys are tight with it. But I'm looking for the quadratic graphs and I'm sure it will be under this thing. Let's save the sequence. By that one. Oh my god. Oh, I didn't know if go for a number journey. Up for you. I'm trying to look for the quadratic graphs, but I can't find it. Page number 371. So questions we say. So in this curve, it says that the graph below shows shows the relation between x and y for -3 and what? So find the maximum value of y. So the maximum value of y is +6. Is D. Are you okay?
Okay.
So it's D. You see, for what values of x is y decreasing? Decreasing means the curve is falling down. So the values of x for which y is decreasing is from this one. The point where this one will get a turning point. Let's say -1.8. But it's not part. Up to this place, if yes 1, yes 1, yes 2, to +1.8. No, 1.4 rather. So this one might be 1.4, yes. So negative to +1.4. So I think it's B. 1.8 is too close to this thing. Now look at this one. It says, look at this graph and use to answer the questions that follow. Find the truth set of the equation 5 plus 4x minus x squared equals 4 minus x. This basically means that look for the points where the line and the graph will intersect. So you just use these points as I'm drawing. I hope you can see my screen. So you use these points when the graph and the curve will intersect. The graph and the curve will intersect. Then you trace those lines to the graph and write it down. Simple. Find the equation of the axis of symmetry. Axis of symmetry always passes through the turning point. So this is the equation for the axis of symmetry. It's passing through the turning point at 2. So x equals what? 2. That's the answer. Are we okay? If they say maximum point, it's the turning point. If they say minimum point, it's the same turning point. But depending on the nature of the graph. Are we okay?
Okay.
Sorry. At long last, I'm tired. I have to sleep. So one thing I would advise you is that if you start solving the question, it's like EMAS now. Go and solve the optional first. The optional one question is 12 marks. Before you come and solve the composed, one question is 8 marks. Exactly. So go and solve question section B. Go start section B. Make sure so maybe section B in there. So obviously I start with. Okay. So get ready for statistics, cumulative frequency curve, histogram, bar chart, and all those stuff. They can come. Okay, so Warren, I wish you the best. All students, I wish you the best for tomorrow. Okay. May I have the quick freeze? Yes.